Welcome to the fourth use case, supporting digital transformation by linking strategy to operations and creating a resilient organization. Digitalization leads to an exponentially higher dynamic in business operations. DevOps is leading to continuous change in products, work instructions, or IT systems. Process mining, as an analysis and tracking tool, allows organizations to retain utility while improving control and hence resilience. So it's important that the business model is documented in a structured way. The business model needs to reflect your way of working, your end-to-end processes, including all relevant aspects like organizational responsibilities, operational risks, and IT applications. Document your business model with your notation of choice, meaning EPC or BPMN. And the role-specific rollout in this way of working allows every single employee to understand the impact of the change strategy to his or her daily work and the employee's personal impact on the company's performance and success. This is essential for the delivery of your best practices and services. Additionally, make sure that management and business stakeholders stay in control. This means the monitoring of the adoption of the strategy, the control of the compliance and risk situation, and the continuous analysis and improvement of the performance along the key processes. Such a scenario will significantly improve the percentage of successful transformation programs and helps organizations to strengthen their resilience. This is achieved by combining operational and contextual data as defined in the digital twin of organizations, using the seamless integration of ARIS and ARIS process mining. Let's start in our central process portal with an overall overview of our processes. We can see in yellow the management processes, in blue our core processes, and in green the support processes. So let's start top down in defining our strategy. This demo revolves around the procurement process. So you'll see the procurement specific strategies. Here you can define how your enterprise creates, delivers, and captures sustainable value. We can see that there's already a risk at this level. Every procurement manager's nightmare is to shut down the plant because there's no more raw materials. To mitigate that risk, procurement processes are put in place, including all the governance and performance analysis. From the strategy, you can derive more detailed objectives. Here, you can operationalize from strategy to measurable key performance indicators. As you can see, the procurement objectives are broken down into increasingly more detailed sub-objectives until you reach the level of the KPI targets in the fourth column of this model. However, this is still static information. So simply pull up the side-by-side dashboard and directly link the KPIs from mining, for instance, on time in full. The next step in strategy modeling is the operating model. The operating model gathers and describes all components that are needed to fulfill the strategic targets. Aligned strategy, in this case, procurement, organizational structure, data models, application landscape, risk and controls, and the process landscape. Here you can see the domain overview for procurement. We can see how processes interact with other processes. The source contract subdomain, procure to pay subdomain, the customer journey map, but from a vendor management perspective. An overview of strategic initiatives, an overview of purchasing or procurement capabilities, and finally, the improved procure to pay process based off of process mining. It's important that your employees understand the end-to-end process model, but we found that only 30% of the people in the world think in terms of processes, so 70% don't. And for that reason, the overview and steps views have been developed. This can be used and enriched with videos and images that are automatically generated via task mining to make it even more easy to understand. The actual process behavior, such as important key performance indicators, can be shown right next or directly on the model. To analyze processes, trends over time, regions or product categories or status like too early or too late, or on time or changes, you can deep dive into a detailed analysis. You can easily filter data, for instance, for processes that take less than 40 hours, which are just the rejections. Between 41 and 80 hours, it's the send back procedure, and greater than 80 hours, it's the full process. We can also easily analyze process behavior and see symptoms, like the step processing invoice is the bottleneck in the means of time. So let's deep dive into ARIS process mining. We can either do a conformance check for this process, or we can do root cause analysis. So we see that our processing time is on average about 3 days. And we want to find out, well, why are we getting longer processing times? So that's why we use the root cause miner. In this case, receiving an incompliant invoice contributes the most to a long processing time. First of all, the average increases to more than 3 days, about half a day longer. And you can see all the additional steps after process invoice, for example, determining the relevant budget holder. To solve the problem, we could get rid of it, or maybe create a software robot to eliminate human tasks. We now save this slow running variant as an input for process improvement. And then after approval, obviously via the process owner, the improved process is rolled out and everyone who's involved can be easily informed via the what's new or model comparison analysis. Additionally, confirmation during the rollout can be requested to ensure that the new way of working can be a success. Well, let's measure the process again. The processing time over time is much faster, with about 2 days in the improved process. But the newest measurements indicate that the process does slow down again. We can see a trend in the behavior. So let's define a business rule and trigger an insights to action workflow. Using insight triggers, we're going to define a workflow or a risk and compliance issue based on certain conditions to send an alert, like we mentioned in previous use cases. The workflow could run in like Microsoft Power Automate or in the Web Methods IO, and send, for instance, emails whenever a defined condition is met. Besides email notifications, an insert action can consist of a complex action flow run by the powerful application stack from webmethods.io. So finally, let's take a look at the data we need and how it's uploaded into ARIS process mining. There are several ways to get access to your data, which is often distributed across different systems via different technologies. You can use Connects to unlock data out of more than 150 legacy systems. Some examples are like vSAM, DB2, but you can also use webmethods.io to build an activity log out of more than 450 connectors. Or you can use stream sets for hybrid integration scenarios. You could use generic extractors like JDBC or SAP or Snowflake for extracting data where you might have restricted access. You can even use Cumulosity for IoT device-generated data like actual production processes or actual delivery of goods to the customer. Or we can start with just a simple snapshot analysis via CSV import. So let's switch to the configuration of systems in process mining. In this case, 2 connectors are configured, one for a legacy system vSAM and one for webmethods.io, calling the ARIS process mining data ingestion API. Let's see how easy it is to combine the data of such various different systems. System integration can be done via the ARIS process mining extractors or via the data ingestion API. Using extractors for JDBC, SAP, Snowflake, or Connects, or legacy systems, we can extract the data out of those source systems. We can also do this in sophisticated ways for things like delta loads to achieve a real-time view into your process. Another way to bring valuable data, where you can construct an activity log, is using webmethods.io connector to one of those more than 450 available connectors. And in this example, the workflow is triggered via a file upload up into SharePoint. And after the ingestion cycle, a dedicated table is created and the data gets uploaded to the ARIS process mining and the ingestion cycle is completed. the data should now be visible as a source table in raw data format. Next, the data processing and ARIS process mining is started in the workflow, and finally, the data from the two different systems are extracted. Data preparation has the following two steps. First, a transformation step and SQL-like approach for data preparation. Second, the data modeling step, where a data model can be defined in a graphical editor showing all the relationships in a convenient ERM style. Finally, uploaded the data from the two different systems, and they're available in ARIS process mining format that can be easily used and consumed by ARIS process mining capabilities, like spotting bottlenecks or via the root cause miner, or even measuring conformance rates. In this part of the demonstration, we're going to demonstrate how Discover data can be used to run the simulation experiment for process optimization. In this case, I want to simulate the 5 most common process variants discovered by ARIS process mining. We can do that by transferring these process variants to the ARIS repository. We've shown this before, but this can be done seamlessly with essentially no effort. So let's take a look at how the model looks in our ARIS model repository. We put a little annotation in here as well. So for instance, on every activity, you see the throughput time discovered by ARIS process mining. Same for these probabilities that were also discovered by ARIS process mining, different paths you go down. There's also a manual adaptation in here. You can see the pool that is displayed here. Behind this pool, we prepared an employee who's working on this process from Monday until Friday, including a lunch break. We could include other employees here, for instance, like a reviewer, an expert, or other different personas that would be useful for the simulation. But let's focus on one persona right now to keep it simple for this case. Now, let's have a look at our simulation cockpit. We want to simulate only a specific time frame, for instance, the 1st of January, 2018 until December 2022. After having all these things prepared, we can now start our simulation. So let's wait until the simulation is done. Finally, we can see that there are a lot of new KPIs on the model. For instance, a waiting time in front of the activities. We can see 6 dynamically waiting events for the activity create purchase requisition and 0 static waiting. More than 8,000 activities have been processed. So we can now transfer this new KPIs and related data back to ARIS process mining for further analysis. In this case, meaning the year 2020, invoice processing or payment of the invoice lasts about 4 days. How could we potentially improve that? Let's have a look on the process role model again. In this scenario, we want to reduce the split amount in here. So to do that, we're going to insert a new activity, check invoice compliance before the split to reduce the split probability to a lower number. Simply place a new activity and reduce the probability from 0.5 to 0.1. Let's run that simulation again and take a look at how it looks like in ARIS process mining. In this case, we see no activity check invoice compliance. We have a throughput time for invoice processing for the payment of the invoice about 3.2 days in the year 2020. All right, let's have a look at how it looks about the process after the redesign. The cycle time has also been reduced from the 4 days we saw in 2019 to 1.2 days in 2021 to 1.16 days in 2022. We can also see the new activity check invoice compliance in our discovered process flow in our activity overview. We have successfully reduced the cycle time of invoice processing to the payment of the invoice. And we can use ARIS to deploy these process changes and communicate and confirm it throughout the organization.